This is a simulation model of an underground mine. You see, in the mining industry you'll get different type of mines. For example, there's an open ore pit mine, or the other way you can get to the valuable resources is to go through an underground shaft, through haulages and into crosscuts. The second one is especially used in your deeper mines, and one of the industries that this is very popular in is in the gold mines found in South Africa. Seen here is a model of a typical mine that uses a shaft and haulages to get to the valuable resources. In this simulation, the ventilation air and the cooling water is simulated simultaneously in order to see the combined effect of the cooling that is required. This cooling is done because of the high temperatures that is found underground, and it is required to cool this ventilation air down because people have to work in the environment. The air that is transported usually enters at the shaft and goes through the tunnel until it splits up into all the different levels where it travels through the haulages. Here is a picture of a typical haulage that you'll find in a gold mine or platinum mine. Now, the ventilation air underground can be cooled down with the use of cooling cars or bulk air coolers. Here is a picture of a bulk air cooler. This bulk air cooler is typically found at the shaft. The ventilation air is usually forced through the system with ventilation fans that's either found in the inlet or the outlets of a shaft or on the different levels. The ventilation air is also cooled down in the haulages or in the crosscuts with what we call cooling cars. Here is a picture of a cooling car that can typically be used. The air usually enters through a big opening in the cooling car, where it goes through thin tube heat exchangers, where water passes through, where it cools the air, and then it exits and the air goes to the place where the cold air is required. As you can see, here is a Flownex simulation of all the ventilation paths in the mine found here, and also pipelines that is added to the system which pumps water to the cooling cars. Now, what is also useful in this network is that the air-water mixture is used for the ventilation air. This is important because the humidity in air usually plays a significant role when it comes to heat transfer. If this is neglected by using pure air, you'll typically find that the answers are inaccurate. This is typically a very great advantage when you use Flownex because you can obtain very accurate answers. Let's solve the model and see what the different functions in the simulation. Let's start at where the ventilation air enters. You see, typically in this case, ambient air is used on the node with a humidity of 54.7% and an ambient temperature of 20 degrees Celsius at a pressure of 100 kPa. The wet pulp temperature can then be calculated to be 14.4 degrees Celsius. As the air goes down the shaft, you'll see that it starts to compress and therefore a higher pressure will be found on the nodes. When you compare it to the lowest point in the shaft, the node representing that, you'll see that the total pressure reaches 113 kPa, and due to the compression effect, the temperature also increased. Now, to cool this ventilation air, it enters through a heat exchanger, which is simulated for these two levels in this vicinity. Now, also part of it is you can see how much heat is transferred to cool the air down and what the exit temperature of the air is. You see it enters here at 35.1 degrees Celsius and it is cooled down to 22.8 degrees Celsius, which is a more acceptable temperature to work in. You can also monitor the amount of mass flow rate going to the different levels. Something that is also part of the simulation then you can also see how much energy your fan typically uses. What is useful in Flownex is when you can add all the different fans together and all the heat exchangers together in a Excel component found in Flownex, for example, and then the results can be summarized, and then you can see how much underground heat is exchanged, how much refrigeration power is then required, and what the ventilation fan power is required to force the ventilation air through the system. This concludes this demonstration of a mine ventilation network in which humid air is used.